All right, so we will go ahead and get started. So this month we have a presentation on monitoring. We sent out kind of a call for interest and we had a few volunteers. Michael's the one who's going to present for us this month. The topic again, Doc, is out there in the chat. Please join us on there and sign in. Topic is an introduction to metrics collection with Prometheus and visualization with Grafana at the Colorado School of Mines. So Michael Roberts is going to lead us on the presentation there. Michael, if you'll just kind of guide us all as you take over on how you'd like us to do questions, whether you want us to interrupt or hold off for times. Troy and I will kind of help watch the chat in case people type questions out in chat to kind of bring that to your attention whenever the questions do come up. But otherwise, we've got the next 50 or so minutes to cover this topic. I'll kill my screen share.
All right, thanks a lot, Brian. If you guys could just go ahead and read me any questions that show up in the chat as they show up, that's fine. Let's see, screen share, PowerPoint. All right, is that showing up fine?
Yep, we see it, but we also see it and the next slide instead of full screen, but however you want it.
You know, get me to see the notes, but that doesn't even show me the notes. That's not what I want. Okay, we'll go with this. Okay.
Looks good.
So obviously I'm not an expert presenter, but I'll do my best here. My name is Mike Robbert. I've been a systems administrator at the Colorado School of Mines since 2001. Working in high performance computing since we got our first central cluster in about 2008. A little bit about the school. We're a relatively small school, 6,000 total students approximately, 17 undergraduate majors, 35 graduate programs, and 84 million in research awards last year. So that's just kind of demonstrating we're a relatively small school in total numbers, but pretty heavy in research. So we like to, try to compete with the bigger schools in research, even though we've got a much smaller size, smaller budgets. So we try to make do with what we've got. And then, so our centrally managed research and high performance computing group is called CaRCC, Cyber Infrastructure and Advanced Research Computing. We're a group within the central IT organization, and we provide resources to all the campus departments. We have a total of 5 full-time staff. We're currently at 4, hiring 1. And we have 3 clusters that are available to researchers across campus. We have approximately 200 active users that are running on the HPC clusters. Here's a quick overview of some of our resources. Our most recent cluster is the Wendian 78 Skylake nodes, some GPU nodes, and a few power nodes running with the BGFS file system. That cluster is replacing Golden, which is about 5 years old now, 144 Sandy Bridge nodes and a GPFS. Mio is in our condo cluster. We've got 200 nodes in there with a few GPUs. That's also running GPFS. And then we've got Orbits, which is our kind of medium to longer term storage solution, 800 terabytes on ZFS that we export to campus using Samba and NFS. So now on to what y'all came here for, was to find out why should we be looking at something like Prometheus and Grafana. We have been using Ganglia since we started running HPC clusters. And Ganglia has worked fine for us, and fairly well. It's easy to deploy. It gives us a good overall view of what's happening in our cluster. And so from that point of view, Ganglia was fine, and we had no reason to change, but there were a few cons that anytime I wanted to add metrics, it wasn't as easy as I would have liked it to be. And so I usually just didn't bother with that. Also, customizing the dashboards. It provides a very good dashboard, but if you wanted to do anything special, I found it difficult to do that. Also, it works well for the primary cluster nodes, but if we wanted to monitor any of the infrastructure stuff around the cluster, it really wasn't well suited for that. Also, the graphing, it does allow zooming, and I think that there were some comparing metric options, but it was a little bit clunky to do that, and not as easy as one would like. And just overall, the interface was feeling a little bit dated, and I always kind of wanted to have something that looked a little more modern. The real tipping point came when we were having a problem with our cluster, and we needed to monitor the voltage coming into the nodes. And some of the nodes were randomly dying due to low voltage errors. And this gets back to the adding metrics. So Ganglia didn't include the node voltage that we needed. And so I started to look around and see, was there something else I could use that would allow me to get the CPU metrics and all of the standard node metrics along with the node voltage. And when I was looking around, I found Prometheus and Grafana, and I was able to stand that up relatively quickly. And so I kind of ran with that. Here's a quick side-by-side comparison of our Ganglia installation and our Grafana installation. You can see that we've got a nice overview on the Ganglia one, and it shows all the nodes. This is actually something, this particular screen on Ganglia is something I haven't so far been able to replicate on Grafana. I know it's possible, or I believe it's possible, but the one time I tried it, I kind of overloaded Ganglia and pretty much crashed my browser. So that's something that we have to work on, but on the Grafana side, I feel it's a really pretty interface. You can do different types of graphs. And if you don't like the way a certain graph looks, you can go in and change it. That's relatively easy to do that. So now I'm going to get into an introduction to kind of show people what the components are and how to install it and whatnot. Here's an overall architectural view that I got from the Prometheus site. So Prometheus is kind of the piece in the middle there. It's used for the storage of the metrics. It pulls from the stuff on the left, and then the stuff on the right is kind of the consumers of the metrics, with Grafana being the main one we'll talk about. And I'll go over some of the details. So starting on the left, data gathering. Exporters is a term that Prometheus uses as its exporters are separate from Prometheus, but they are integral in actually collecting the metrics, and they run as a service, usually on the nodes where you're collecting the metrics, and then they just expose those on a TCP port so that Prometheus can pull them in. A metric, I kind of give a definition here of a metric is any time series data. There's counters, gauges, histograms, basically any kind of numbers that are gonna change over time, and that you want to see how they're changing. And then another key thing here is labels. Labels are just key value pairs that are attached to the metrics, and they allow you to give some dimensionality so that you can do different types of queries to pull different metrics into different graphs. And then I also mentioned that there is a push gateway that is part of Grafana, or part of Prometheus. I keep saying Grafana. The push gateway allows for pushing of metrics, but they make it very clear that it's not meant to turn Prometheus into a push-based system, and that the push gateway is only meant for ephemeral, short-lived jobs that wouldn't allow for pulling at all. If you think that you need to push metrics, like if you're behind a NAT and you want to push them out from behind the NAT, there are other ways to do that. But don't try to use the push gateway to do that.
Hey, Mike?
Yes?
There's a couple questions. One, okay. I think you partially just answered, that was in chat, that just kind of asked, is Prometheus a receiver, or does it sample? So I think you covered that, unless you want to add more to that one.
No, yeah, pretty much. Prometheus is the Prometheus server pulls from the exporters. The exporters are just a service that runs, and then when the Prometheus server sends an HTTP request to the exporter sends it JSON data, but it's completely a pull model. Okay. And then with the exception of the push gateway. But I think even the push gateway is essentially a pull model. I don't know a whole lot about that, but yeah, it's pull.
Okay, so the other question was put in the Google Doc, and it says, did you look at other metrics collection schemes like InfluxDB and Telegraph?
I did a little bit, and when we get further down the line, I will mention that all of those, or most of those, are available as options. Grafana can use multiple data sources. Prometheus is just is the preferred one. I don't know that Prometheus and Grafana don't appear to be like one in the same, but they do have they both kind of push users to each other. If you look at Grafana, they say that most of their documentation says, Prometheus is their preferred way to get metrics. But if you have a different metrics collector already that you like, you can probably use it with Grafana. So I looked at those, but I just found it easiest because I was starting from scratch to use Prometheus.
Okay, it looks like there's one more that just asking if Elasticsearch tools can be used to ingest raw data and if that then can be pushed into Prometheus.
Elasticsearch, yes. I don't know much about that, but I know I've seen Elasticsearch as, wait, was the question for Prometheus or Grafana?
Probably for pushing data into Prometheus, but there's part of an answer that somebody else offered there, which is that Grafana doesn't really care where the data is, meaning Grafana can source data from lots of different places. Right. Not everything has to be in Prometheus. So.
Right. So that's where I would say if you have data in, if you already have the data, you can probably graph it with Grafana. There might be some cases where it might make more sense to massage the data and pull it into Prometheus, but I would look at accessing the data directly from Grafana as the first way to do it.
Thanks.
Okay. So here I just wanted to show just kind of a sampling of the available exporters. So these are things that you can get, your metrics from. I tried to include some that would probably be more appropriate to this audience. There's a much more extensive list. You can follow the link there. And even if you just do Google searches, there's even more than what's on that list. But they have stuff for Luster, HDFS, Ceph. And here you can also see, you can take stuff from like CollectD or Graphite and pull them into Prometheus. But again, those are things that I believe are also available directly from Grafana. So if you're using something in that other monitoring systems, you may want to look at whether it's easier or better to get that straight into Grafana rather than pulling it into Prometheus, but it's available. All right, the next step here, after you've set up your exporters to actually, access the metrics, the Prometheus server is what will pull it and then store it. That's where the metrics, that's where the big, the database, that's where you need all of your disk. Prometheus wants to store the metrics on local disk to avoid any other dependencies. There are options for remoting that or sending that to remote targets. That's kind of an advanced option that I haven't looked into much, but it is available. But the primary storage should be local disk on the Prometheus server. There's also a concept of service discovery. And in this picture, they show Kubernetes, but the service discovery is also available for all of the cloud providers, so your AWS, Google, and Azure. So if you're doing, kind of dynamic environments, that allows you to not have to define each node manually. It can just query, Kubernetes or AWS and say, what do you have out there? But for our setup, we mainly use just the file service discovery or just straight up static configurations because our clusters are fairly static. So I created a script to generate the files is all I did. And I, if we make any changes on the cluster, I can just regenerate that. But for the most part, it's pretty static rather than any kind of dynamic service discovery. Time series database is kind of a generic term. Most of these metrics collection programs have some type of time series database. In this case, Prometheus uses its own format. They don't use anybody else's. Then the term scraping, we kind of already talked about this. Scraping is the term that Prometheus uses to pull the metrics. You set up jobs and then it scrapes is the term they use to do the pulling of the metrics into their time series database.
So there's a question kind of related to that.
Yep.
It says, do the exporters store the metrics on the local node in clear text JSON format? And then kind of the follow on is, can exporters exist independent of Prometheus?
No and yes, but the shorter answer is no. Exporters typically don't store the data. The exporter is just a binary that's running that when it's queried, it knows how to go and get the data from the data source. So it usually gets it in real time. There is a concept of having, I forget what it's called, but a file that if you can't directly pull your data from the binary, then you can write it to a file and the exporter can read from that file, but that's not the way that it normally works. So normally the exporter pulls it directly from whatever it needs to from, proc file system, or, if it's MySQL, it pulls, MySQL, does the queries itself. So the storage is, the only storage you really need to worry about is on the Prometheus server.
Thanks.
And what was the second question?
I think you got both there. Well, the second part was, is can the exporters exist independent of Prometheus?
Yeah, the exporters essentially are independent of Prometheus. Sometimes you'll run an exporter on the same server, like we do IPMI and SNMP, because so we'll run the IPMI exporter on the Prometheus server, and then it does the queries, out to the remote server via IPMI or SNMP. But most times the exporter is separate from Prometheus, and they can be, but none of the exporters even ship with Prometheus. When you download Prometheus, all you get is Prometheus, and you have to do the exporter separately. Their documentation, will point you to some of them, but it's a separate process. The next thing I'll just mention quickly is that Prometheus has an alert manager. We are not using this, so I can't tell you much about it. The only thing I will say is that Grafana also has alerting. So if you're going to look at doing alerts, you may want to look at Grafana's alerting and compare it to Prometheus alerting. That's not something that I've done yet, so I can't tell you which is better, but both of them do have that as an option. And then the final piece is data viewing. The Prometheus server provides its own web user interface. It's good for debugging or seeing what your metrics look like, and kind of, for building panels to build the queries. You can use the Prometheus web UI. But again, in recent versions of Grafana, they've kind of added that feature into Grafana as well. for kind of exploring the metrics. And I'll hopefully get to show that a little bit later. But the main piece is Grafana itself. Grafana is it's just the data viewing. So again, all of the storage stays in Prometheus or any other data source. And then you build panels, but a panel is the basic visualization building block based on one or more queries of a data source. And so you can build, do a query for your metrics out of Prometheus, and that goes into a panel. You can do more than one on a panel, or you can separate them into separate panels, and then you take multiple panels and they create a dashboard. And again, I think this will make more sense when we take a look at the interface of Grafana. Grafana also has the concept of plugins. So most of what you'll need to start with ships by default in Grafana, but they have a whole library of additional panel types, which would be different types of graphs, and also data sources. So there's a few that are built in, mainly, Prometheus is built in as a data source, but if you have, something else, definitely look on this web page, and they can pretty much anything that has data that can be graphed. They probably have a plugin that you can just plug into Grafana and use it. So now we'll get on to installation. First step is installing Node Exporter. So one thing I don't think I explained earlier, that there's a bunch of different exporters, but the primary one that pretty much everybody's going to use is called Node Exporter. And that takes, it gives you basically all of the standard statistics or metrics that a standard host might provide. And so that's kind of the first one you want to start with. And if it's not in Node Exporter, then you start looking at some of the other exporters. But all of the documentation kind of starts you out with Node Exporter. It ships as a tarball with just a single static binary. So there's no dependencies. You just grab that tarball, put it into a place, user local bin. They don't even ship the init script in the tarball, but they do have examples in their GitHub repository. So you can go there, get the init script, either systemd or system5, and then start that up. It will listen by default on port 9100. And there's a lot of optional stuff. By default, it'll scrape all of the basic stuff, but you might want to take a look, use a -- help to, see what some of the other options are for Node Exporter. There might be some stuff like the one that I found for our ZFS installation was that the Node Exporter, you can turn on some of the ZFS metrics and it'll pull those for you. And then so it's basically just a listening port that listens for HTTP requests. And so you can test it with curl. You just, curl that URL on localhost and it'll spit out a whole bunch of metrics. And that's how you know it's working. Next step is the Prometheus server. Prometheus server itself is also just a static binary. They include a few assets, I think mostly for the web UI. So there's a little bit more in the tarball that they ship. But the one thing, Prometheus server doesn't appear to provide any in its script at all. So I had to do a little Googling to find some examples, and I've included ours here on the right. The main part is highlighted with the exec start. You can pretty much just point it to your config file, point it to a path that you want to store the time series database, and then start that up. It listens on port 9090. You can browse to it using a standard web browser, and you'll get the web UI. And then you can kind of see what there. Final step is the Grafana server. Grafana ships with RPM or Debian packages. But the thing that I really liked about it, a lot of these newer, web interface stuff seems to have this, whole list of dependencies you have to install with it. But with Grafana, they've packaged it up into, again, I believe it's just a static binary. And so their RPM package has very minimal set of dependencies. It's mostly stuff that's already installed. I think a couple of font RPMs were needed. Also wanted to mention that Grafana does have an enterprise version if you need commercial support. I believe pretty much everything is available in the open source version. The only thing I found missing is their SAML support for authentication is only available in enterprise. So that was kind of a bummer because we use SAML, or we prefer to use SAML. I have ours configured to use LDAP, and that works fine, but it would have been nice if we could have used SAML. They also have cloud hosted versions if you want to go that way. Real simple, system control start Grafana server, and it's up and running. There's the Grafana.ini is for advanced configurations. If you need to change some paths, if you want to do SSL, you put your certificates, you have to define your certificates in there. It stores some, just the like configuration for panels and dashboards in a database. It uses SQLite by default, but if you wanted to, you could switch that to a real database like MySQL or Postgres. But you don't need to touch that in order to get a simple server up and running. Now I've got all three components installed. Let's talk a little bit about what configuration you need to do. Typical workflow is that you're gonna add your exporters. We've kind of already done that with the node exporter. And then you need to tell Prometheus to scrape those exporters. Then in Grafana, you'll add Prometheus as a data source. Then you start adding and importing dashboards. And then optionally set and customize some variables and customize your panels. That's kind of a typical workflow for getting things running. So yeah, I didn't include anything for the exporter there because the node exporter is pretty much config free unless you want to turn on any of the advanced features. So within Prometheus, you've got a Prometheus.yaml. This is just an excerpt of the part that I had to add. So I created a new job. It's a new scrape job that I called compute. I told it to do file service discovery, and all of my files are in the directory that's listed. And then on the right is an example of what one of those files looks like. It's just another YAML file. points to the target. C001 is that compute node. Port 9100 is where the exporter is listening. And then I added some custom labels saying that this is the cluster Wendian host C001, and it has a role of compute. So we have, storage nodes, we have GPU nodes, and so I can have different roles. And if we wanted to, set up special panels within Grafana that show only those, you can add those to the queries. So that's what the labels can be useful for. Then here I created a short video to show how to add a data source to Grafana. And so this is, so you go to the gear icon on the left there, data sources, add data source. We're going to do Prometheus. Select that. Give it a name that's useful. If you have multiple Prometheus sources, you may want to, do one per cluster or something like that. Type in the URL for the Prometheus server. And then there's a whole bunch of other options there, but those are all kind of advanced things that for the most part you shouldn't have to use. And that's it. Once you see the little green thing there, it says data source is working. It should be working. Oh. All right. And so then once you've added the data source to Grafana, you can add a dashboard, but adding a dashboard gives you a blank slate, and there's lots and lots of metrics available. Even just the node exporter has, I didn't even count, but I'm guessing hundreds of different metrics, and setting those all up by hand is would be very time consuming and tedious. And so Grafana has a dashboard site where people have taken, already put together dashboards and, exported them to the site, and you can go and browse that. So, pick one. The one that I found to start with what was called Node Exporter Full, which claims to get just basically a simple graph of the full set of node exporter metrics. There's many to choose from. So you have to kind of look at the number of downloads, number of reviews, and maybe look at a couple different ones sometimes to find one that you like. Then it's a real simple, once you've found the one that you like, you click, they're all identified with an ID, and that ID can just be pasted into Grafana when you're importing. And then once you've done that, you set a name, you tell it what data source to get its metrics from, then start editing it. One problem that I found with a lot of these pre-configured dashboards is people will make certain assumptions the way they did things. And so there's variables or hard-coded labels that they can put into their dashboards that sometimes make them not work. And so if you import a dashboard and expect it to have data and it says that there's no data there, then you need to go and start looking at some of the variables or the hard-coded labels and see, what's different about the person that saved this than my setup. And at this point, I think it makes sense to just to start looking at a demo, because Grafana is a very visual thing. And so I thought about doing some screenshots and just thought it wasn't going to do it justice. So let's see if I can figure out how to get out of this. where's the right window? I think it's that one. All right, is that showing my Grafana dashboard?
No, we're still seeing the slides. I'm not sure if when you started the share,
Okay.
if you limited it to the one.
How about now?
So now we're on a web page, Zoom Help Center.
Okay, I chose the wrong window. Got too many windows open. There we go. Is that it?
Yep, there we go.
Okay. So the one we're seeing here is our Slurm data. Let's switch over. Node exporter full. This is again just using the node exporter data, and we've got this set up to look at all the compute nodes in our cluster. So along the top here, we have, these are the variables that we can use to change what we're looking at. It's set to the job compute. We've got our orbits, that's our ZFS. But let's stay on this one. Our list of host names here, so we can switch to a different host. We see the graphs for that. This one came with a variable for the port, but we're only getting one port on our metrics, so we don't need that. Quick little tour. We got time picker here. It's real easy to switch between whatever time frame you want to see. I want to see a whole day of data, and then I say, okay, something happened here. Highlight that. Zooms into that time for you. If you want it to be updating off to the right here, I can say update it every 10 seconds. So now it'll go grab new data every 10 seconds. So that there's two different gear icons. The gear icon on the left is for the overall configuration, but if you're configuring a dashboard, there's one up at the top. So we can go into the dashboard settings. And this is where I was talking about the variables. So sometimes, when I configured Prometheus, I configured a certain job name. And some people will either hard code this or they have a different way to query it. And so that's something that you often have to change when you're importing. Let's see.
There was a question kind of thrown out.
Okay.
So the question says, how does the performance affected, like when you're zooming or when you're looking at an entire year's worth of data?
I've never looked at an entire year's worth, so I don't know. But I think when you go to the larger time scales, I definitely see a little bit of a slowdown. So yeah, it's taking a little bit longer. But remember that this is pretty much all in the browser. So definitely it's between the browser and how fast your Prometheus or whatever your data source is can return the query results. But for the most part, I haven't had huge performance issues unless you have lots and lots of metrics in your queries. So there's certain dashboards that I've tried to create. That's where the performance really becomes a problem, is if you put too many metrics, or if your query is returning too many data points. So like on ZFS, I had one that was looking at data from all of the hard drives or all of the disk devices, and I think there were 120 disks, and they were in a multipath setup, so there were just way too much data.
So Larry has a follow-on kind of question. He says, how do you set up aggregation levels? And I guess he gives the clarification that he's kind of focused on the Prometheus kind of end of these things.
Aggregation of what?
Looking, see if Larry, you're welcome to unmute yourself and do a better job than I am trying to re-represent your question. He says the 1 minute versus 5 minute versus 2 hour versus 1 day aggregations.
That's just built into Grafana. Grafana is just querying Prometheus for a particular time range. And so it's not aggregating. That may be one thing to point out. If you're used to something like Ganglia or anything that uses RRD files are meant to, over time, kind of aggregate the data into less, what would it be, less precise, so that you have, so that you have month views and whatnot. Prometheus doesn't do that. So that's one thing I didn't mention is Prometheus is not meant for like long-term trending, because all of the data, the data gets written as like raw data in like 2 hour increments, and then it compresses it for longer term storage than 2 hours, but it doesn't aggregate data so that you can have an overall view of an entire year. If you want to store an entire year of data, it's storing it without any aggregations. That's something I would like to find out if it's possible, but I don't know how to do that yet with Grafana or with Prometheus. Is if you can automatically get it to export and be able to get some trending data over an entire year. So if I try to show, well, I don't even have a year because I haven't been using this for a year, but I think that I've only got 30, maybe 90 days of total data. This is really meant more for troubleshooting near-term problems, something that's happened in the past week, and you can store a little bit more data than that, so that you can have kind of a baseline, but it's really not meant for long-term trending. And if anybody else has any questions on things that they want to see in here, definitely tell me. At this point, I'm just kind of trying to think off the top of my head things that I think are really cool and want to show off.
So Jeremy just typed one in. He says, does Grafana have role-based access controls to segment what customers see? And then he follows up with, and is that authorization given in Grafana, or can you use remote services like LDAP to do that?
It does have role-based access control, but I think that the capabilities of it are kind of limited. So we use LDAP, and you can configure LDAP groups to have view only or edit or admin access. Those are basically I think those are the only 3 levels. So if we go discard, so we can see some users here. And then you can see I'm set up as an admin. I can click change role. Yeah, so there's admin can do anything in Grafana. An editor can obviously edit, and I believe they can create new dashboards, and then viewer cannot make any changes to any of the dashboards or panels. But I believe, I forget where I was reading this, but there was a kind of a bug report that, you know, somebody wanted to do that, where they wanted to make certain data only available to certain users. And I don't believe there's a way to do that. If a user has access to Grafana, they essentially have access to any of the data that's stored in the data sources. So if you needed to segment your data, if you had some stuff that you wanted to make sure that a certain group of users couldn't access, I think that you would have to segment that at the Prometheus level. You would have to send some of the data to a different Prometheus server, and then maybe set up a different Grafana instance that can only access that restricted Prometheus server. Yeah, most of this is kind of based on the premise that anybody that's looking at your statistics should at least be able to view all of your statistics, anything that's stored there, and that, you know, none of this should be sensitive. I'll note that all of the node exporter and Prometheus by default, there's no encryption. All of that's, you know, sent clear text HTTP. There are options that you can do that, but that's up to you.
But I guess I would add kind of a refinement question on that, is with the way you said that, then if I did have a reason to segregate data, maybe I could go and set the, you know, more public Prometheus up and the more private Prometheus up, and then I could have a Grafana that was set up for the public consumers that would only pull data from the public Prometheus, but my other Grafana instance that I might set up that's more for the, you know, internal group that can see everything could pull data from both of us, meaning I really wouldn't have to replicate the data. I could have the Grafana on the inside pull from both the public and private Grafana and not have to replicate the data between the two, but just use multiple data sources.
Yeah, that would be a good idea, that you could set it up that way rather than having to choose. In fact, I don't even know if there's a good way, because I haven't looked at how Prometheus can do, you know, what are the options for replicating data. I know that there were some options for remote data sources or remote data storage, but I don't know exactly what the capabilities of that were. So yeah, you would probably want to say all of your private data gets stored on one server, all of your public data gets stored on another server, Prometheus servers, and then, like I said, have a different Grafana instance that could view both and one that could view one. That's a good idea.
So Dylan throws out a question here, I think related to compute nodes of a HPC type resource, about kind of the overhead, the white noise.
Yeah, I expected this question. And the short answer is I don't know what the overhead is, but I would say it's good enough that I don't notice, but I'm not running, you know, exascale size jobs that are, you know, sensitive to jitter. So if your jobs are very sensitive to jitter at the OS level, you would probably need to do some testing to see if the node exporter, if the polling of the node exporters cause too much jitter for jobs that it cause problems. But I haven't noticed, but I'll admit that I don't pay that close attention. So I don't know.
We've got a couple other questions in the Google Doc. One is, how did you determine your storage requirements?
I started small and just kind of watched it. But I'll say it wasn't, yeah, there is one of the, yeah, I don't know if I'm going to be able to find it, but Prometheus does somewhere have a calculation where you can actually do the math on it. I don't remember exactly what that was, but basically I started with the defaults, and obviously it's going to start small, and as you get days and weeks of data, it's going to grow. But I basically set it up and prayed that it didn't fill up my disks too quickly. And I had enough disk space on the server that I set it up on that I wasn't too worried about that for the size installation. But if you have a very large installation, you would definitely want to find that page in the on the Prometheus site and kind of do the math. Actually, I think it was this one. Yeah, needed disk space, retention time in seconds times ingested samples per second times bytes per sample. And they say 1 to 2 bytes per sample is typical. So that's how you could do it. I will say I didn't do it because I felt our site was small enough that I wasn't gonna run into a problem.
Another question in the Google Doc is, did you remove any metrics from the exporter to prune?
From the node exporter, I did not. Well, I don't think so. I think the only thing I did was add some stuff. But that's definitely an option. Like I said, when you run the node exporter with -- help, it gives you a whole bunch of options and tells you which ones are on by default. You can definitely turn some of those off if you know that you don't need them. But I haven't gone through that exercise of saying that I knew I didn't need something, so I didn't bother turning anything off.
So there's a question that I meant to ask as well, which is, would you be willing to share your slides so that we can link it into the Google Doc so other people can find them again later?
Yeah, definitely.
Okay, so I'll follow up with you that later and put the link to wherever we get those into the Google Doc. Okay,
great. Yeah, that was the other thing I kind of wanted to mention, is that I don't want people to think that I'm a total expert on this. I just offered to give this because I was really kind of excited by how easy it was to set something up that could give us, this kind of flexibility of viewing metrics, and really wanted to show it off to the community because it offers a lot of options for sharing. And so the more people we get using this, is that we should be able to share. If people start building dashboards that work really well with HPC clusters or other infrastructure around HPC, they can share dashboards. You can all of the stuff behind the dashboards and panels is all just JSON. So it's real easy to look at and modify if you need to. It's not, you should never have to touch the JSON itself, but the fact that it is just, raw text JSON makes it easy to share.
All right, well, we're at the top of the hour almost. So if there's any last minute questions to throw Mike's way, let's quickly throw them out. If not, we really appreciate Mike's time putting this together and guiding us through what you guys have been able to accomplish.
Yeah, thanks for inviting me.
All right. I think with that, we'll call today good. And again, I'll follow up with Michael and get the link to slides and share that out with everybody.
Great, thanks.
Yep. Thanks everybody for attending.